We all know floods are getting more frequent and a whole lot more severe. And right in the middle of all that chaos, the #1 challenge is finding clarity and finding it fast. That's where a totally new way of seeing, powered by AI, really comes into play.
I mean, we have eyes in the sky, right? Drones, satellites, they give us this incredible bird's-eye view of disasters. But here's the thing. Just looking at a picture isn't the same as actually understanding what's going on. So the real puzzle, the real challenge, is how do you teach a machine to look at all this chaos and pull out information we can actually use? Actionable intelligence. How do you even do that?
And that is the exact problem we're going to dive into. This urgent, pressing need for better AI tools that can accurately figure out the impact of floods and help us, limit the damage.
Okay, so to build a really truly smart AI, you need data. And not just any data, you need a massive amount of diverse data. And the foundation for this whole new approach we're talking about, it's a data set covering, get this, 230 separate flood events.
And look, we're not just talking about one region or one type of flood here. The data we're digging into today comes from literally all over the globe, from Africa, Asia, Europe, the Americas, you name it. And having that global perspective, that is absolutely crucial if you want to build an AI that can actually work anywhere in the world.
So all this leads to a pretty obvious question, right? I mean, we have these incredibly powerful AI models, amazing computer vision, so why haven't they solved this problem already? What's the holdup?
Well, the answer, and this is the key, isn't the AI itself. It's about what we've been feeding it. You've probably heard that old saying in machine learning, garbage in, garbage out. It's totally true. And for way too long, the data we've had on floods, well, it's had a huge blind spot. And this quote from the research paper we're looking at, it just nails it. Basically, the old data sets were just too narrow. They'd focus on maybe one country, or they just didn't have the super fine-grained detail you need to train an AI to be really, truly effective.
So, let's break that down a bit more, right? Like we said, a lot of the older data was geographically stuck, maybe focused only on the US, for example. The level of detail just wasn't there, a lot of it was from older, less relevant floods, and it totally missed the huge variety of environments. Everything from dense cities to open farmland where floods actually happen.
So, to fix all of this, researchers built something new. It's called AIFloodSense. And what it is a brand new, super comprehensive, and this is important, publicly available dataset. It was designed specifically to fill that massive data gap and, well, to give AI the vision it's been missing.
And when we talk about detail, this is exactly what we're talking about. I mean, every single image has been marked up, annotated, right down to the individual pixel. Just look at this chart. Almost half, 47.5% of all the pixels in the whole dataset are labeled specifically as flood. That level of precision is it's unbelievably important for teaching an AI exactly what it's supposed to be looking for.
So yeah, this is what makes AIFloodSense a total game changer. It's global, so it covers all those different environments. It's recent, using images from just the last couple of years, so it's relevant. The images are super high resolution, and maybe coolest of all, it's built to teach AI to do more than just one thing. It's a multitasker.
But look, having a great data set, that's just the beginning. The real question is, how do you actually use it to build a smarter AI? And the answer, it turns out, is to teach it 3 core tasks.
And these tasks, they kind of build on each other. You start with a pretty simple, high-level understanding of a scene, and you gradually move up to this really deep, detailed, and even interactive way of reasoning about it.
Okay, so first up is classification. Think of this as level 1, the most basic task. Before it can even spot the floodwaters, the AI has to learn to understand the context of the image. Is it looking at a city or a rural area? Is the camera pointing straight down, or can you see the sky in the shot? Getting that background info right is absolutely vital.
All right, the next step up is something called semantic segmentation. And this is where we get back to that incredible pixel-level detail we were talking about. It's about going way beyond just slapping one label on the whole image. Here, we're classifying every single part of it. This slide really shows it perfectly. This is what segmentation does. It takes that complex, messy, real-world image on the left and it turns it into that clean map on the right. Every single pixel gets a color code. White means flood, dark gray is a building, black is just background. It's like giving the AI a high-definition coloring book of the disaster. It's a precise digital understanding of the whole scene.
And that brings us to the final and most advanced task, visual question answering, or VQA for short.
This is basically where the AI graduates. It moves from just seeing things to actually reasoning about what it sees. You know, a person can look at a really complex scene like this one and make sense of it almost instantly. For an AI, this is ridiculously hard. So VQA is designed to train the model to look at these chaotic scenes, interpret them, and then pull out very specific, critical bits of information.
So think about it. Instead of the AI just spitting out another map, a first responder on the ground could ask it a direct question, just using plain English. Something like, hey, how many buildings are flooded in this picture? And the AI could actually analyze the image and give back a straight answer. I mean, that is a massive leap forward.
Because, at the end of the day, all this complicated tech, all these pixels and algorithms and data sets, it's all about one thing: helping people.
So what's the real-world impact? Why does this matter? Well, with an AI trained on this kind of data, we get way faster, much more accurate damage assessments. That means we can get the right resources to the right places faster. It can lead to better early warning systems, and ultimately, it helps us build smarter communities that are more resilient to climate change.
Yeah, the ultimate goal here is to create tools that can actually keep up with our rapidly changing world. Tools that give us that desperately needed clarity in the middle of a crisis and help us plan for a safer future for everyone. This new way of seeing things, it's incredibly powerful. And it leaves us with a really exciting question to think about. If we can teach an AI to see and understand a flood in this much detail, what's next? What other huge global challenges can we teach it to see and help us solve?